1% of all the carbon in any sample is carbon-13. Carbon-13 has 7 neutrons, so it has a spin. So we can take a carbon-13 spectrum, not a carbon-12 spectrum. And so we can cover the two big things in organic chemistry. Deuterium has a spin, but it's a weird spin. It's not the same kind of spin as we're talking about here, so you typically don't see it in the instruments we're using. And phosphorus is probably the only other one that's useful because there's a lot of phosphorus in biochemical molecules, and so you can do a phosphorus NMR to see what the environment of the phosphorus atom is in the molecule. So in any case, what we're going to focus on is these two, protons and carbons. So they both have a spin. In particular, they have the so-called spin 1/2, which means there are two possible ways in which these nuclei can spin. And what does spin mean? Well, again, we don't know. It's something that comes out of the math and physics, and you get some factor which says it could be either plus this or minus that value. But we do know what it's like. It's as if a nucleus so if you think of the nucleus as a little charged ball, which it is, and if you think of that nucleus as spinning on an axis, that's what we call nuclear spin. All nuclei are going to spin, so the connection is not there. But it's as if a nucleus was spinning on an axis, and because a nucleus has a charge and it's spinning, it's going to generate a magnetic